All right, so we're getting into lesson 3 of Unit 13, which is just a comprehensive review of all the stuff that we've talked about over the course. And this one specifically covers comparing the key features of functions. So what are the key features of functions, right? Well, the y-intercept is a key feature of functions. So key features, we're talking about like the y-intercept, the change in y for a given change in x, which is like the slope for linear equation. Or you're talking about like a constant change or a constant factor for your b value, right? So your growth factor of an exponential function. Um, and there's x-intercepts, of course. X-intercepts. There are when is it going up? When is the function going down? When is it positive? When is it negative? Are there any asymptotes? That type of stuff, right? Just to be able to describe a function, which is just a line, right? It's just a comparing an x value to its y output. Right? So how does y change as x changes? That's what a function is, right? Two variables. Okay, so we have 3 functions. We have this function, y equals mx plus b, right? Y equals m, which is some slope, times x, which is the variable x, plus b, right? So this is a linear function. It's a linear function. Okay. Here we have to look at our changes in x. Our changes in x for each one of these is plus 1, plus 1, plus 1, plus 1. So to go from here to here, we added 1, or we added 1. From here, we added 1. Go from here to here, we added 1. And we go from here to here, we added 1. So our change in x equals plus 1, right? Which now we can evaluate how our y changes from here to here, right? If it was a linear equation, it would be, what did I add to get to the next one? So it would be plus 3, then plus 1, minus 3, then I go to minus 1, then I'd go to plus 1, and then I go to plus 3. So the change in y is not consistent. I don't have a b value, so it's not linear, right? So what about my change in x, or what if it was an exponential function? So what is the difference? What is the factor difference between here and here? So 1 divided by 4 is a fourth. 0 divided by 1 is 0. So it's not a consistent factor difference, right? So it's not exponential. It's not exponential. Okay, that means it must be quadratic, right? And if you kind of like look at this thing, if you like made a little plot, right? And so this one is -2 and 4, -1 and 1, 0 and 0, 1 and 1, and 2 and 4. You could have just done that from the very beginning and be like, oh yeah, that's quadratic. That is definitely a parabola, right? Parabolas are quadratic. So it's like that. Okay, so it's definitely quadratic. And this one is obviously exponential. There's an asymptote right here. All right, that's why I like looking at the graphs. Right, there's the asymptote right here. It as x approaches negative infinity, right? As x approaches negative infinity, as x approaches negative infinity, y approaches 0. So that's the asymptote, y equals 0. Okay, so x approaches the asymptote, and then as x approaches infinite, positive infinity, y approaches infinity as well, right? So this is exponential. So which one of these has the larger y-intercept? Well, this one's y-intercept is 2. This one's y-intercept is 0. This one's y-intercept is like 5. So this would be C. Okay, compare the ranges of the functions and indicate the dissimilarities and the differences. Okay, well, function A looks kind of like this. Function B and function C. And let's do like a real quick little loop, like that, and like that. Okay, and then we already have, this one. Function C already looks kind of like this, like that. Function B, we already said, kind of looks like this. That does not like that, but kind of like this. It's hard to do this little scale. Zoom in a little. Looks like this. Okay, that's pretty good. Not a straight line. It's not an absolute value. Those are curves, right? And then this has a 2 to 1 change in y for change in x, and it's gonna intercept at 2, so it's gonna look something like this. I'm gonna say that's 2. That's 2. Okay, so what is the range? The range for this is all real numbers, right? So where does y, what is the up and down, where does this function live? Like, where does the line exist for values of y, for the up and down? It's all real numbers. Any value of x will give me any value of y, and it's continuous throughout infinity. Okay, so for B here, well, it's never going to be down here. It's never going to be less than 0, right? You can see up here, it never went less than 0, right? So the range for this one is all values of x such that x is greater than or equal to, because it could be equal to 0, right? Or equal to 0. Okay, and then this one again is similar, right? It's never going to be, the range is the same. Except almost the same. It's almost the same. It's never going to be negative, so it's never going to be less than 0, and it will never be 0, right? Because it's going to get infinitely closer to the asymptote as x goes that way, right? So this is the range is the set of all values of x. Oh, this should be y's. I'm so sorry. This is y's. What am I thinking? So all values of y such that y is greater than 0, and all values of y such that y is greater than 0, as compared to greater than or equal to 0. Right, so this one is all real numbers. The range for this is all real numbers. Okay, actually, I guess it should be like this to be technical. All real numbers. Okay, this is the set of all values of y such that y is greater than or equal to 0. And this is a set of all values of y such that y is greater than 0, but not equal to. Okay, now the domains. The domains for this is anywhere where x exists horizontally, right? So the domain for this is all real numbers. The domain for this is all real numbers. The domain for this one is all real numbers. There is no value of x that y doesn't exist. Okay, so there's that. Okay, so as x approaches infinity, which function has larger values of y? Well, that's easy. That's going to be the exponential function, right? Exponential functions get bigger fast, right? So as x approaches infinity, which is over here, right? As x approaches infinity, right? Y is going to approach infinity much faster than this one will, right? Because you can see at 2, which is like right here, right? This is only at like 4 when I'm already above 4 right there, right? So this one is linear. This one is just going to have the same ratio of change. So exponential functions grow significantly faster. So this is going to be C. Okay. All right. So here is a table representing revenue in billions of dollars. So this is billions. Let me change. I don't like to. This is billions of dollars. Okay, billions of dollars, right? And this represents X, which is 2015. This is year 0 at 2015. I'm going to just write 2015. So this is 16, 17, 18, 19, 20, 21, and this would be like 25. No, 22. 22. Sorry. Can't even count this morning. This is 22. Okay. Because 7 minus 5, or 22 minus 7 is 15. Okay. And here is the digital. This is, okay. So graphs. Okay. It looks like they show it in 2 different ways. Oh, this is 2 different graphs. This is book sales and this is movie sales in billions of dollars. So this is 2 different graphs shown 2 different ways. Okay, so book sales is going down. It looks like movie sales are going down too. Okay, so let's approximate the x-intercept for the function, or approximate the x-intercept for the value that represents the digital books. So this is books, approximately, we'll say the x-intercept, that's when it reached 0 billions of dollars of digital book sales. Is 2020, sorry, 21. So this is 21 right here. That's 21. So this is like 21, or this is like the x-intercept is we'll say like 3.75 ish, approximately 3.75. So that's 3 months. So what interpret the x-intercept of the function for this? What does this mean? So at 6.75 years after my start date, so 2021 and like 3/4 of the year. So let's see, there's 12 months in a year. Each quarter is 3 months. So in September, approximately, book sales reached 0 billions of dollars. Book sales, the digital book sales reached $0. Okay, so what's the domain representing the sale of digital functions of books? Remember, the domain is where this value is in my first quadrant. Nothing is negative. So it's in quadrant 1. So it starts from here and it goes to here. This is my domain. It is between, my x value is between these 2 values, and they can equal these 2 values. This is my 21 point. This is my 6.75 on there. So this is what we're looking at here. So it's 0, 6.75. Remember, we're using the labels for the x-intercept, not their meaning. So 6.75. So x is in between 0 and 6.75. So it's all values of x, such that 0 is, this is the wrong way. I do this a lot. 0 is on, x is on that side of where this, no, I was right. I was right the first time. No, I wasn't. So x is greater than 0, but less than 6.75. It could be equal to, right? So x is greater than 0 or equal to 0. And it is less than 6.75, but it could be 6.75 too. So it's less than or equal to 6.75. And if we want to be super specific, right, we'll say integers z divided by 100, right, because we're getting into 0.75. If you wanted to be like super awesome, because z is integers, an integer divided by 100 is hundreds of the increment, which is what we're getting down into the, oh, no, that's wrong. That is wrong. It should be z divided by 12. Divided by 12, if you wanted to break it down into the months, I guess. So yeah, there's that one. I mean, if you want to break it down to the days, you could be z divided by 365. But it depends on how you want to show your data. Okay, which function has a larger y-intercept? Well, when x is 0, y is my y-intercept. So this one has a y-intercept of about 2,000. That's my b value. This one has a y-intercept of 152524. So this is bigger than that, right? So book sales. Okay, at 2,000. Okay. All right. So which table best describes the values of the movie sales? Well, let's see. What is the change between here and here? What is the difference? Looks like we lost about 200 and some stuff. All right, so let's get out a calculator and get the exact value. 1525 minus 1401. The difference is 124. Now, what's the difference between this one and this one? What's the difference of 1401 minus 1275? Those are 126 apart. 126 apart, which is really close to 124. Right? And what's 12575? 1275.67 minus 1149.23 is 126. Right, so it looks like we have a pretty consistent difference between the x and the y. So this is going to be a linear. As explained, the delta y divided by the delta x, or the differences. So the difference in x, right? So x's are the same, right? Changing one, so it'd be 124 divided by 1, 26 divided by 1, 26 divided by 1, right? So the change in y over the change in x is approximately 126. It's consistent. It's consistently, or it is consistent. Right? So change in y over change in x is a slope. So it has a consistent slope. Right, so that's one way to look at it. Okay, so I think that is all of section 3. I hope that you learned something from this and it was helpful.